Hi. Today we're gonna start about studying structures in C's implementation. So this is a part 2 lecture for structures in C. So we'll see how structures can be implemented using C programming language. So let us use dev C++, which is the IDE for C and C++ that I am used to use always. So we'll start with this. So we will put the first header file normal, then int main, this also show. If you're putting structure here, or you can define the structure inside the main. So if it is outside the function, it's a global definition. So first we are going to define the structure. So I use struct keyword. So design a structure for a say student, closing ending and ending with the semicolon. That's the student's structure. So structure members, a student can have a name, you can give a 15 say character length, and there is a int age, there is a say float CGPA. These three are the members: float one integer, one character array. So these three primitive data types are together forms a data type called struct student. So struct student is a single data type. We've defined this. So this is called structure definition. I define the structure outside. So here we are going to declare variables of type struct student. Struct student. Say there are two students A, B. So these two are variables, A and B are variables of type struct student. So these two variables, each variable size is, say size of this variable A is 4 plus 4 plus 15. So 24, mostly 24 bytes will be the size of the one minimum size for A. So if there is a padding added by a compiler, it will be somewhat more, but that's a size can be a combination of all the sizes of my individual members. So size of A is that much, size of B is this much. So these two structures are created. If you want to see the size of structure, I can just see printf %d. We can use size of A. We can see and find out how it is printed. Let's say it is C source file. Structure. Compile and run. So you see, size of structure is 24. So that's a combination of 4 for int, 4 for float, and 15 for character array. Each 1 byte, 15 bytes. Totally 24 bytes. So that's the size of A. So when you declare a 24 bytes are allocated. The same way, when you declare this B, 24 bytes are allocated. These two are called structure variables. Now I want to store data inside the structure variable. How to store data inside the structure variable? If you are using a structure variable directly to access its members, there are three members for this. Then you can use what operator? Dot operator. We already seen this one, dot operator. So if you want to put A dot age equal to say 20, the same way B dot age equal to B dot age equal to 22. So that's the age. CGPA, if you want to put A dot CGPA equal to 7.5. The same way B dot CGPA equal to 9.2. So that's the CGPA float value and integer value. And there is one more, name is also there. So I want to put name. So name we cannot use equal to in C, so we have to use strcpy in the place of left side a dot name. Right side I want to just put this value, say ram. The same way strcpy b dot name, and so I can put say Lakshmi. Likewise we can put. So two things. So name is stored in name member, age is stored in age member, CGPA 7.5 is stored in CGPA member. Likewise you can store. So if you want to find the display and see how it is stored, so if you do printf %d and a dot age, you can just compare and run. So I will disable this. You can see 20, age is 20 is printed. So 20 is printed. So you can print this way. If you are printing CGPA, you can just change it to %f and you can just say CGPA. It will print 7.500 and all 6050. So totally 6 digits because it's a float. So 1.5 is stored. So 5 followed by 5 zeros. If I want to display the name, there are some ways. Printf I can use. In case of printf, what you have to put, you have to use %s, then a dot name. This way we can display RAM is displayed. Otherwise you can use put as just a dot name. This one I can comment on. So this is a way to access elements RAM. So it will add one new line character. That's thing. When you use putters, it will add a new line character after this display. So these are all the ways of displaying. Printf here, printf here. I can just this is the integer. Yes, I can display like these manners. So this is the way. I'll just keep it commented out. And this is the input we are hard coding, directly giving the values. Other way of getting is you can use a scanf. I can just %d ampersand a dot age. You can get from the user. The same way scanf %f ampersand a dot CGPA, ending with the semicolon. Before that I can just put a scanf, or I can use a getters a dot name. The same way you can use for B also. For B's B member, there are two members. One is a member A, member B. So a struct student A, I am getting for the student, first student. The second student B, for them also we can get a name, age and CGPA. So in this case, if you want to enter, so we are entering age is 22, CGPA is 8.4. So if you want to display and see, I can just remove the comment port. So it is going wrong. Second one is age is 822, 8.4. So 22, 8.4 followed by 5 zeros and ROM it's printing. So all are coming. So this is a way to get values into the structure members, and this is a way to print it. So one way is hard coding directly with values, or you can get from the users the same way. So it's assignment operation using single equal to. It is from the keyboard entry. So scanf is scanning the keyboard, std in file, get us everything is a keyboard access. So these stories are the ways. So for the present scenario, we'll just go with the some hard coded values to for the study purpose. So we'll just comment out these things. We are having age, everything stored. So AB having values. So these are two numbers, AB member, A member with values. Now, if I want to access via some other means, there is a structure pointer. We already discussed structure pointer. So when I declare a structure pointer, this declaration like this: struct student, say star m. So when we use a star for a variable, then this variable m, there is a star before that. So we are mentioning that m is going to be a pointer variable. The pointer variable stores the address, and that address points to this struct student. So m is a variable which stores an address. That address is pointing to a structure member. The structure member size is 24 bytes. The structure member size is 24 bytes. But what's the size of m? Because m is a pointer variable. M stores just an address. Address is nothing but a integer. So m will be having only 4 bytes. So if you print m, you will be able to see only 4 bytes for that. So if I print the size of m, in this case, comment down to size of m is a pointer variable. It is not a structure. Structure means 24 bytes for these members combined together. But this m is just a variable which stores address. It's a pointer variable. So in this case, probably it should be having 8 bytes is the long one. Okay, for the integer, it's a long int. So it's a bigger version of a integer. So 8 bytes are allocated. Always, whenever you declare a structure or whenever you declare a pointer variable, the pointer variable will always have 8 bytes of memory. It's nothing but a long integer. Integer usually 4 bytes and long int is usually 8 bytes. So it is not a structure. A is a structure, m is a pointer to a structure. So now m is not pointing, m is just a pointer variable, but we didn't make it to point any structure. So after this one, we assign some values here and making m to point. So m equal to, m stores the address. So address, ampersand is the address of operator, address of a. Say for example, a is a structure, a has values of age 20, CGPA 7.5, name member is Ram. Now that A's address, the 24 byte is there, the 24 byte starting address, the starting address for the 24 byte chunk of memory, the starting address is stored in m. Now m stores the starting address. So if you want to print and see what's the address, I'll just print and see what's the address that is stored in. So I'll comment on this. So now size of m, instead of size of m, we'll just print m. What is stored in m, we'll just get it. So what is present in m? M stores the starting address of the structure, which is nothing but 24 byte memory. So this is the address stored over there. So if you see, it's ending 6487552. This is the address stored in m. That's nothing but a starting address of a. So I remember of a is also this one only. So here we have a starting address stored over there. That's the address. From that starting address, we got 24 bytes. Say if you see this address, it's ending with 552. This is starting address 552. From this address, we got 24 bytes. for this first byte address, you can just have it like that. 24 bytes from this address, we can just have it as a this one starting address. 24 bytes will be having for entire structure. If you want to see the ending address, you can just put a pointer arithmetic. I can just do a m plus 1. So m is of type struct students, so it's a pointer arithmetic. So n will move the size of the struct student. So struct student size is 24. So if you see, it will just move 24 bytes. So it was 55. So for example, we'll just put both together. M and n plus 1. So m is 552. 24 added, it is 576. So it's a pointer arithmetic. So that's the address. So next address is what is pointing to. So m is a pointer variable, it stores address, starting address. When I do m plus 1, it just moves 24 bytes because it's a pointer of struct student. Struct student size is 24. That's why. So m's movement and all you should be able to know. It's like a normal pointer operation. So it's a pointer arithmetic. Now we have this thing. M is equal to ampersand of A. M is ampersand of A. M points to a structure. So how to access the structure members, which is age, CGPA, using a pointer variable, structure pointer variable. So in that case, we have to use arrow operator. So it's m arrow. Arrow is put up like one hyphen and then followed by a greater than symbol. So age, m dot age is equal to, say, 25, equal to 25. M CGPA equal to 9.5. I'm changing 2025 and 9.5. So now if I want to print and see how to print and see the same grades, not much different, but just we have to just change the dot operator to arrow operator. So arrow operator. So in case of m, which is nothing but a pointer variable, so we are just changing it to arrow operation. M and CGPA. So now if I compile this and run, let us see what's happening. It's so it is coming 25 2 point. So I can just put a backslash n. I'll compile and run it. So it is 25 9.5. So it is 25. Earlier it was 20. Now I have changed this. M is pointing to A. A is 20 earlier. Now I overwritten with a 25. So that's why it is printing 25 age. Earlier CGPA is 7.5. Now we have overwritten with 9.5. So that's what this 9.5 display. But I didn't change name. So if you want to put us m name, so it will directly give name display. So RAM is printed. So this is the way to use structure pointers. So now we have seen what we have seen: structure student definition, and there is a B of struct student is a structure declaration itself. This is structure definition, structure variable declaration of 24 bytes of this nature, this one size, and m is a pointer variable of 8 bytes, but it stores address. That address points to struct student. So if you are using A, I will be using dot operations like this, A and B. If you use directly the structure variables, you have to use dot operator. If you use a pointer variable, then you have to use a arrow operation this way. So the how to get print of everything. Yes, in the same way we can use scanf for scanf too. If I am getting some values using pointer variable, I can just, instead of this hard coding, if you are planning scan of A, so I can come out and just say scan of D. So in this place we can just put a M arrow H CGP. So it scans and it's it. So it's waiting. So I'm just giving age as say 33, CGP as say 8.9. .55 9.5. We missed the ampersand. Kind of needs ampersand, the address of. So ampersand M of this way. So earlier it was 20. We just put as a 55 and 9.5. So I inputted 55, 9.5. It displayed 55 and 9.5. So using this arrow operator, how to get and how to print it. Using dot operator, how to get and how to print it. We have seen all these. And the size of pointer variable of structure is always equal to 8 bytes, which is nothing but a pointer variable. It is not a structure. It's not a structure variable. This thing is, you should be very careful. This is not a structure variable. It's a pointer variable. This pointer points to a structure, but A and B are directly the structures. A is a structure, B is a structure, but M is a pointer to a structure. So with this, I close this session on structure usage. Next session we will see array of structures.